welcome to Cambridge Chemistry channel. Be sure to subscribe the channel and like the video. Really helps the channel to grow. Today I will discuss the quantitative analysis of paper 3, question number 1, and today I will discuss the titration which is known as thermometric titration. It is the titration in which the end point is determined by measuring the temperature of the solution. So read the question very carefully. So read through the whole method before starting any practical work. Where appropriate, prepare a table for your result in the space provided. Show your working and appropriate significant figures in the final answer to each step of your calculations. The reaction between the reaction between acids and alkali is exothermic. You will find the concentration of monoprotic acid. Monoprotic acid in which one hydrogen ion is present in the acid. This is Hg by thermometric method using a solution. This is thermometric titration or thermometric method in which the end point is determined by measuring the temperature of a solution. Sodium of known concentration Hg, sodium hydroxide, NaZ plus water. Fa1 is solution of acid Hg whose concentration is unknown, and we have to find out concentration of this acid by using this method. Fa2 is 2 mole per dm cube sodium hydroxide. Method, read the method very carefully. Place the thermometer into Fa1, record the temperature of Fa1 in the table. This is the temperature when the volume of Fa2 is 0.0. Rinse and dry the thermometer. Place the thermometer into Fa2, record the temperature of Fa2 in the beaker. This is the temperature when the volume of Fa1 is 0.0. Fill the burette with Fa1, support the plastic cup or polystyrene cup in the 250 centimeter cube beaker like this. This is 250 centimeter cube beaker, and place the plastic cup in 250 centimeter cube beaker. This is the cup, and we use this to minimize the heat loss. Why we place beaker in 250 centimeter beaker? To minimize the heat loss. In this way, support the plastic cup in the 250 centimeter cube beaker. From the burette, transfer 35 centimeter cube of Fa1 into the from burette. This is the burette. In this way, we place the burette and transfer 35 centimeter cube of Fa1 into the plastic cup. This is Fa1 in the burette into the plastic cup. Use the 50 centimeter cube measuring cylinder to measure 5 centimeter cube of Fa2. This is the measuring cylinder. We measure 5 centimeter cube. Let's say this is 5 centimeter cube of Fa2. Transfer the 5 centimeter cube of Fa2 into the plastic cup. Stir the mixture and record the highest temperature. You place thermometer over in this. This is the thermometer. Place thermometer over here, and you can stir with thermometer as well. Shake it, stir the mixture and record the highest temperature. Tip out the solution, rinse the plastic cup, tip out the empty this beaker, this cup, and rinse the plastic cup with water. Shake it to remove excess water and replace the cup in the beaker. Rinse and dry the thermometer. So thermometer also should be rinsed and dry. So next, use the burette to transfer 30 centimeter cube, now 30 centimeter cube of Fa1 into the plastic cup, and use the measuring cylinder to transfer 10 centimeter cube of Fa2 into the plastic cup. Stir the mixture and record the highest temperature. So tip out the solution, rinse the plastic cup with water, shake it to remove excess water and replace the cup in the beaker. Rinse and dry the thermometer. Continue the experiment using the volume of Fa1, Fa2 again after 30 centimeter cube, 10 centimeter. By applying the same method, you will take 25 centimeter cube of Fa1 and then Fa2 is 15 centimeter cube. So repeat the experiments and take 1, 2, 3, 4, 5, 6 more reading by using the same method. Continue the experiment using the volumes of Fa1, Fa2 given in the table and record the maximum temperature of each mixture. Now record the temperature. I just write down the suppose reading over here. Like for example, if the 22 degrees centigrade over here, and let's say this is 23.0, because first temperature is increased and afterward temperature is decreased. This is 24.0, 1 decimal place. 24.0 and this is 25.5, this is 26.0. So temperature is start dropping down, 24.0, 23.0 and 22.0. So in this way you can you will complete the table. Now plot a graph. So this is very important to read out these instructions, because these 3 marks, if you want to get 3 marks, then read these instructions very carefully. Plot a graph temperature of solution. Temperature of solution y-axis against volume of Fa2. Temperature of the solution, write down the name of the quantity along with unit on y-axis, and this is temperature. We need to take temperature on y-axis because according to the instruction, and we need to take volume of Fa2 along x-axis, and Fa2 is the volume. Write down the volume of Fa2 along with unit, volume of Fa2 along with centimeter cube. Select a suitable scale on the y-axis to include a temperature of 2 degrees centigrade above your maximum thermometer reading. Label any point you consider anomalous. So this carrying this 2 points carrying 1 mark. Then draw 2 lines. Then plot all points correctly plotted carrying 2nd mark. All points plotted correctly carrying 2nd mark. Then draw 2 lines of best fit, one for decreasing and another for increasing. Best fit through the points on your graph, the first of the increase in the temperature and the second for decrease in the temperature of the mixture. Extrapolate the 2 lines so they intersect. So you have to draw 2 lines and then extrapolate the 2 lines to ensure that they intersect at any point. So this point carrying third marks. So now on y-axis, like this, write down temperature, degree centigrade, and along y-axis volume of Fa2 centimeter cube. So, and there is another point that choose the scale in such a way that your graph occupies more than half of the graph length. So this is 20, 21, 22, 23, 24, 25, 26, 20, 27, 28 and 29 degrees centigrade. And over here 0 0.05, 10, 15, 20, 25, 30, 35, 40 and 45. So my first line reading is over here, second reading is 23, third reading over here, reading is 1, 2, 3, 4, 5, 25. So 25 is nearly about, this is now by so draw the line with scale. This is first line, and this is anomalous point, and this is second line. And you extrapolate, draw these lines with scale, and this is the intersect line. So we use this line to measure the volume of Fa2. This is the end point of this neutralization. So it means 20 centimeter cube of Fa2 required to neutralize Fa1 solution. Now this is the temperature of the solution at the end point. So draw the line very carefully with ruler. .8. This is the maximum temperature. Now next question is the intersection on your graph occurs at the volume of Fa2 that reacted to form a neutral solution. Determine the volume of Fa1 and Fa2. We have Fa2 from graph and total volume is 40 centimeter cube. 40 minus 20 is equal to volume of Fa1. So this is equal to 20. So 20 centimeter cube and 20 centimeter cube of Fa2. Calculate the number of moles of sodium hydroxide required to obtain a neutral solution in this experiment. Moles of sodium hydroxide, we have concentration as well as volume. 20 divided by 1000. So the answer is 0.04 moles of sodium hydroxide. Hence, calculate the concentration of Hg in Fa1. So the concentration, we know that concentration is equal to mole over volume into 1000, and this is equal to 0.04 divided by 20 into 1000. The answer is 2 mole per dm cube. So the concentration of Hg is 2 mole per dm cube. Explain how you would use the data obtained to calculate the enthalpy change of neutralization. You do not need to carry out the calculations. Okay. Since we know that neutralization is exothermic reaction, since neutralization is reactions are exothermic, and the final solution will increase in temperature. By measuring the maximum change in temperature the amount of energy produced by neutralization maximum change in temperature can be calculated by using temperature maximum minus temperature initials of average initials of two solutions, sodium hydroxide and Hg solution. So in this way we can calculate the change in temperature. The amount of heat energy produced by neutralization and absorbed by the solution can be calculated by using Q is equal to mc delta T. We know m is mass of solution C is specific heat capacity of water, and delta T is the temperature change. In degree centigrade. Now enthalpy change of neutralization is calculated by using Q over N. So like Q is equal to, delta H is equal to over N. And we know that delta H is the neutralization and enthalpy change of neutralization. N is the number of mole. Q is the energy absorbed or released. So enthalpy change, there is a negative sign in the calculation of delta H, because Q represents the energy absorbed by the final solution, while delta H represents the energy released by neutralization by a mole of water. So there is negative sign in the calculation. This is very important to understand. In the calculation of delta H, because Q represents the energy absorbed by the final solution, while delta H represents the energy released which is negative by neutralization by 1 mole of water. So since the value of Q will always be inaccurate due to the unaccounted energy loss, there will be discrepancy between the theoretical value of delta H of neutralization and the experimental value. So the delta H of neutralization always taken negative, or sign of the enthalpy change of neutralization is always negative, because heat released is more than the heat absorbed. So hopefully you got this question. Thank you.